Now we have S of t. Let S of t be the length of time in hours from the start of the Martian day until sunset at point A on day t. S of t can be multiplied by this function. The length of time between sunrise and sunset at point A, L of t, can be multiplied by this function. Find the value of d. Okay, so essentially what we have is, let me just fix this. Okay, so this was R of t. This was the length of time from start, R of t models, start of day to sunrise. That's start of day to sunrise. And this is start of day to sunset. So the time between sunrise and sunset is just this minus this. Now note, guys, there's a few different, you'll notice in the mark scheme some of the answers are slightly different to my answers. Don't worry too much about them. It's only due to rounding, so don't worry too much about the rounding. And here he's using 1.6, even though it's 1.59 whatever. The model is 1.6, and that's why at the start of the question he actually says assume all numbers given are exact. So this is actually the exact value for his model. But essentially what he's done is he's taken the model that's start of day to sunset and subtracted start of day to sunrise. So if you get the start of day to sunset and you subtract the start of day to sunrise, what happens is you get the time between sunrise and sunset. So it's essentially this S of t minus R of t will give me L of t. So L of t it's essentially S of t minus R of t, which gives me this minus this, again rounded to 1.6, plus some d. But we know that d has to then be the 18.65 minus the 6.15988. So for part G, all I have to do is do 18.65 minus 6.15998. Again, the mark scheme is slightly different, but it's all good. It's just, and you'll notice it even says just accept answers that are slightly different due to rounding. They're not trying to penalize students for rounding in this question. That's definitely not the point of it. So 6.15998 gives me 12.49. So D is 12.49. Okay, that's part G.